Hello, this is Mr. Huber. In this lesson, we're going to look at solving equations. We're going to see many different types of equations, but we want to keep in mind the basic premise for every equation we want to solve is that we want to simplify both sides of the equation first. Then we want to isolate the variable by using inverse operations. We want to isolate it on one side of the equal sign. Sometimes the variable is on both sides. We want to get it onto one side of the equal sign only, and we're going to use the reverse order of operations as we go through this to solve our equations. And then always remember to check your solutions and check them in the original equation. Always check solutions in the original equation. We'll show some of that as well as we go. Right? Remember, inverse operations are ones that undo each other, such as addition and subtraction. Okay? And when we perform those inverse operations on both sides of an equation, we keep the equation balanced and equal on both sides. So we have to remember that when we do an inverse operation to undo something or to cancel something out, we have to do that same thing on both sides of the equation. Okay? And as we go through these, feel free to try any of these on your own you want, pausing the video to try them and then seeing how I do them. I'm not going to pause myself through, I'm just going to work through them, but you should at times pause, try the problems out, and see if you're on track with them. Okay, so let's check out a first couple here. We've got negative 11 equals negative 5 plus h. So we want to look at the variables on the right side of that equation. And just because we see a plus sign here, okay, there's this plus sign right here, that does not mean that we're going to subtract on both sides. We want to undo and do the inverse of the negative 5. So we're going to add 5 to both sides. Make sure it's on both sides of the equation. If it helps, draw a line right down the middle and keep it balanced on both sides of that. So when that negative 5 plus 5 cancels out to 0. We don't have to write the 0, okay, because 0 plus h is going to be just h. So we have our equal sign, and on this side, on the right, we have just the h. Then we have negative 11 plus 5, it'd be negative 6. So that's the answer to our equation. How do we know if that's right? We plug it back in. Plug it back into the original equation. We're going to get negative 11 equals negative 5 plus negative 6. Negative 11 equals negative 5 plus negative 6 is negative 11. That works. It's the same on both sides. That's how we know that that is the right solution. The solution to that equation is h equals negative 6. All right, and then as we work through, we go to the one to the right of that, and we see x over 3 equals negative 9. Remember, a fraction is division. That's x divided by 3. So we can multiply both sides by 3. That would be like 3 over 1. So that's why those 3's cancel. Dividing by 3 and multiplying by 3 is 1. We'd have 1x. Again, we don't have to write the 1 there. 1x is just x, which is what we want. Equals negative 9 times 3 is negative 27. Again, we could plug that back into the equation. We'd have negative 27 over 3 is negative 9 equals negative 9. We've got a correct solution. Try a couple more here. In number 3, we see a fraction. It's a little bit different than the fraction in the last problem. In this one, we have negative 2/3 m. So to cancel out a fraction, we can multiply by its reciprocal. We talked about reciprocals in a previous section, and you've seen them before. If we multiply this by negative 3 over 2, anytime you multiply reciprocals, you'll get 1. So now we have 1m. And on the other side of the equation, we want to multiply by negative 3 over 2. Make sure, since this was a negative 2 over 3, we multiply by a negative 3 over 2. Okay? And so now we multiply on both sides here by the negative 3 over 2, and we'd have to do 18 times negative 3 over 2. There's a couple different ways you could do that. Okay? If you write this as 18 over 1, then we could reduce these two fractions. That'd be 1 and that'd be 9. And that'd be 9 times 3 is negative 27 over 1, which is just negative 27. Right? If you want to use a calculator to be able to do those things, that's helpful as well. That's fine. Make sure you know how to use the calculator to do fractions and things. Okay, we have m equals negative 27. All right. In number 4, we have 7 equals negative 6w plus 25. So we could subtract the 25 on both sides. And we get 7 minus 25 is negative 18 equals negative 6w. Let's say we dropped that negative sign. Okay, let's say we forgot that. I'm going to show you how to catch a mistake you might make. So if we did that, and then in the next step we divided by 6 and by 6, that would cancel out, and we get negative 3 equals w. Well, let's check it. Okay, I'm going to write it up above. So we're going to check x equals negative 3. So I'm going to have 7 equals negative 6 times negative 3 plus 25. Okay. So now, in this problem, I'm going to have 7 equals 18 plus 25. Negative 6 times negative 3 would be a positive 18. That'd be 7 equals 43. That's not true. 7 does not equal 43. We'd be able to go back and see in our problem, where did we make a mistake? And if you check your answers, you might see, oh my gosh, I just dropped a negative sign off there. And then now, when you divide both sides by negative 6, okay, you'd end up with a positive 3. And if we plug a positive 3 in, it will work. We'll find out that that's the right answer, and we know that W, in fact, equals 3. So make sure you're checking your answers. Don't just assume they're going to work. Check them. Make sure that they work. We see a couple more examples here. We'll see some with decimals and fractions. Sometimes you see decimals, fractions, you think it's going to be harder or you don't know what to do. Handle the problems the same as you would have any other time. In this first example here, 1.5x plus 0.9. We want to subtract the 0.9 on both sides. So we're going to have 1.5x equals 4.5. Now we're going to divide by a decimal. That's okay. We divide by 1.5 on both sides. So that cancels out, and we're going to have x equals 4.5 divided by 1.5. That's 3. And we go back and check it in our original equation, and we'd be good. Okay? Always make sure you're checking in the original equation. In number 6, again, so we have 3/10 plus y over 4. Okay, subtract the 3/10 on both sides. Is that a little harder than subtracting integers and things like that? Sure, but we can still do it. And we have y over 4 on the right side. And on the left side, we have 2/5 minus 3/10. Okay, so we might need to get a common denominator. That's 10 and 4. 2/5 is the same as 4/10. So now we have 4/10 minus 3/10. That's 1/10. Make sure you're comfortable working with fractions. If you're not, let's practice them, talk to me, let's see some ways we can help you out, and make sure you're more comfortable working those down in the future. And then we have y divided by 4, so we're going to multiply by 4 to cancel that out. That gives us the y all by itself. On this side, we multiply by 4, and if we want that 4 over 1, that's fine. Then we can reduce, dividing them both by 2. We have 2 over 5. So y is equal to 2 over 5. Again, some different examples, different things. Keep in mind what we did on all these problems, what we started this off with. We want to isolate the variable on one side of the equation. We're going to simplify first. Then we're going to work on making sure the variable is only in one location on one side of the equal sign. We'll see somewhere we have to do that coming up. And then we're going to use those inverse operations, right, to cancel things out and get that variable isolated. All right. Let's take a little roll in the dice here. A roll of the dice. What is the name for the dots on a die? So you've got these dots there, right? Right here, right? You got a dot here, you got a dot here, you got these dots around here. There's a name for them. Everything's got a name. They're called pips. You might be wondering why that picture is there with this. What does that have to do with it? Well, that's Gladys Knight in the Pips, old Motown group. So anyway, pips are the names for those dots on dice. Something you probably didn't know and probably wish you didn't know, but now you do. All right, and number 7 here. Again, be pausing and trying these as we go. You might see where you're making mistakes. This is the time to figure those out. So on number 7, we're going to have some simplifying to do. Okay? We can distribute that 3 into the parentheses. We'll get 2w plus 3w plus 12 equals 27. Now we can combine these two like terms here. 2w and 3w is 5w plus 12 equals 27. Now we can look at using our inverse operations. Now it should look a lot like the equations we saw previously. And that's what happens a lot of times. When you simplify these equations down, they start to look more and more like ones you've already solved. Okay? So we get 5w equals 27 minus 12 is 15. And now if I divide on both sides by 5, I get w equals 3. Remember, if you're going to check that, go back up here, plug it into the original equation for both places where you have a w. Okay? When you check this, it would look like 2 times 3 plus 3 times 3 plus 4 equals 27. Then we'd have 6 plus, in the parentheses here, 3 plus 4 is 7, so 3 times 7 would be 21 equals 27, and we get 27 equals 27, which checks. So we know that's a correct answer. So when you're checking your answer, make sure you plug it into the original equation. Okay? Don't plug it into one of your steps further down where you think, oh, I know, I can just plug it in somewhere else. Maybe I'll plug it in, right here, or one of these spots. No, plug it into the original equation, here and here. Always check your answer by plugging into the original equation. Okay? In this next example, similar to what we just saw, be careful with distributing the negative 2. You're distributing the negative in there. So it's 46 equals 10x minus 6x plus 10. That's 46 equals 10x minus 6x is 4x plus 10. And now we can start using our inverse operations on both sides of the equal sign and get 36 equals 4x. And when we divide both sides by 4, we get 9 equals x. That'll be our answer. Again, if you check it, plug it into the original equation. All right. Just a couple more here. As we look through, let's look at number 9 next. Okay. On number 9, we're going to distribute as well a 3 that's negative, so make sure you're paying attention to the negative signs. So you have negative 12x plus 15 equals negative 12x minus 6. When you have variable on both sides here, we want to add that 12x to both sides. That's going to cancel on both sides. We're going to get 15 equals negative 6. So what does that mean our answer is? Is 15? Is it negative 6? It's actually neither. Does 15 equal negative 6? No, it does not. So there's no solution. There's no number you could plug into that equation and have it work. You can try numbers all you want. You keep plugging them in for x, nothing you plug in will work. So if you get a problem where the variable cancels out completely and you're left with a statement that's not true, that means there's no solution. In this next example, we see a fraction there, 1/4. You can distribute the 1/4 if you want, or you can multiply both sides by 4. I'm going to show you both ways. Okay? So first, if we distribute that 1/4 into the parentheses, multiplying by 1/4 is the same as dividing by 4. So 16 divided by 4 would be 4x. And then we'd have 60 times 1/4, again, which is the same as 60 divided by 4 is 15. Now we can subtract the 4x on both sides. Let's fix that, not 14x, 4x. Okay, so we're going to subtract 4x on both sides. That gives us 5x minus 5 equals 15. Then if I add the 5 to both sides, we're going to get 5x equals 20. And get used to showing all these steps. Don't try and do them in your head. Don't try and solve these problems in 1 second. Some of them might take a minute. It's okay. But be disciplined in showing your work. From the one you think is the simplest to one like this, it might take several steps. Show the work. You're going to get in good habits then. They're going to pay off down the road. And x equals 4 would be our solution for number 10. I said I'd show you another way to do that. So let's do that now. Okay. In this example, since the 1/4 is multiplying the entire side of the equation, we can cancel that out by multiplying by its reciprocal right at the beginning. Okay? So our very first step here could be to multiply both sides of this equation by 4. The 1/4 and 4 are going to cancel each other out. Those cancel each other out. And then we distribute the 4 on the other side to get 36x minus 20 equals 16x plus 60. We don't multiply the 16x and 60 by 4 because they're being multiplied by 1/4 and 1/4, which have canceled each other out. And now we can solve the equation from here. We subtract 16x on both sides. And we get 20x minus 20 equals 60. And if we add the 20 on both sides, we get 20x equals 80, which then if we divide by 20 on both sides, we get x equals 4, which is the same answer we had the other method. So a couple methods there that'll work on that problem. You can use either one. Find the method you're comfortable with and practice it regularly so you get good at it. That's the key, is you get good at practicing a method that then you can use consistently well. Okay, in this next problem, I want to show you a couple things to avoid in particular you'll see on this problem. So if I multiply this 5 into the parentheses first, I get 3x plus 4 plus 2x equals 5x minus 5 plus 9. What you want to avoid doing, do not subtract 2x to cancel it out. What did I just do? I subtracted 2x twice from the same side of the equal sign. I'd have to go and subtract the 4x over here to balance that out. That's not what I want to do. So be careful. These are like terms on the same side of the equal sign. I don't need to subtract 2x to cancel it. I just combine the like terms. I combine the 3x and the 2x to get 5x plus 4 equals 5x plus 4. At this point, you might start to recognize they're the same on both sides. When I subtract the 5x on both sides and it cancels out, like the one above this, where the variable canceled out on both sides, I get a statement then with no variables, right? Up here in this problem, I had an example where 15 equaled negative 6, right? The 12x canceled out on both sides, there's no variable left, and I ended up with no solution, okay? If I come down here to this, both variables canceled out again, right? I subtract the 5x on both sides, x canceled out, and I'm left with 4 equals 4. In this case, 4 does equal 4. That is a true statement. Since this is a true statement and 4 always equals 4, there's all real numbers as a solution. You could pick any number you want, and if you plugged it in for x in all three of these spots, okay, if you plug in for x here, here, and here, any number you want, it'll work if you do the calculations correctly. So all real numbers are solutions. Sometimes it's referred to as there's infinitely many solutions because there's no end to the solutions. Okay? The key there is when the variable cancels out on both sides, look for one of these situations. If you get something like 15 equals negative 6, that's never true, no solution. If it's always true, you get like 4 equals 4, then it's all real numbers. Okay? So get in the good habits of practicing writing out the steps for solving these equations. Get used to checking your solutions back in the original equation. That'll help you out. When you're taking quizzes and tests, it's good to know if you're getting them right before you even turn it in. That way you have a chance to correct mistakes you can make. So we'll practice some of these equations. Make sure you're practicing them and showing those steps and doing them the right way. So when you practice them the right way, you'll get used to performing them the right way as well.